All right, so in this video, we're going to pick up where we left off 2 days ago. Some of the problems in this handout are brand new, and some of the problems are actually the homework problems due for today. I included the homework problems in the handouts for students who were absent 2 days ago. So if you were here 2 days ago, got the homework problems, got it completed, you don't have to redo the problems in this handout. So problems are there specifically for students who were absent. So we're starting off by squaring each of these terms. And so we talked a little bit about what happens when we're doing a square of a square root problem. And so if you go ahead and complete the 4 problems and then turn the video on when you are ready to check your answers or want some additional information to help you through the problems. Please keep in mind that the goal here is for you to try to complete as many of the problems as you can on your own. Try to figure out what's going on. Use the video as a way of getting some additional information, but the idea here is not to watch me complete the problems and just simply copy down the answers. But try to make sure from your own growth that you are going through the process of trying to figure out how to square a square root problem and end up with the correct answer. So when you finish, turn the video back on. So we talked about a couple of days ago, anytime we're taking this squaring a square root, those are inverses of each other, so essentially they're making canceling each other out or creating an exponent, in this case of 1. Since the square root has exponent of half, and if I take and half multiplied by 2, that gives me the exponent of 1. So what we talked about a couple days ago is if I take the square of 9 and square it, and we end up with the answer of 9. The square of 9 is 3, and 3 squared is 9. The square of 25, we squared it as well, and again that answer is 25. So the squaring of a square root, basically that's going to create an exponent of 1. So what we're left with is that value that's underneath, or expression that's underneath the square root. So the first problem here, the answer would be 2z plus 1. In the second problem, we're squaring 2 things. We're squaring the square root, and we're also squaring the 12. Again, as we're working through these problems, if at any point I say something and it goes, oh yeah, I remember what to do now, stop the video, complete the problem, turn the video back on when you're ready to continue. So this problem here, we're squaring the 12, and we're squaring the 7w, square root of 7w. So the square root of 12 squared is 144. And the squaring of the square root of 7w is simply 7w. So we end up with 1008 w. In the next problem, again, we're doing the same thing. We're squaring both things. We're squaring -5, and we're squaring the square root of w minus 9. So -5 squared is 25, and the squaring of the square root is w minus 9. In this case here, we're still doing multiplication, so like we did in the previous problem. So we need to multiply the 25 to the w minus 9 expression. So that means to get rid of the parentheses, we have to multiply the 25 not only to the w, but also to the 9. So we end up with this 25w minus 225. And then the last problem, we're squaring, again, both things, both factors. So we have 3x minus 2, square root of that being squared, and square root of 5x also being squared. So in the first one, the answer becomes 3x minus 2. In the second one, the answer is 5x. Like the previous problem, where we're taking 25 times both things in parentheses, we'll be doing the same thing in the last problem as well. So 3x times 5x, that's 15x squared. And -2 times 5 is -10, so -2 times 5x is -10x. So I started off on this page at least, with some problems that were similar to what we did 2 days ago, and they kind of ended with new situations with where we have to actually multiply the factor to parentheses using the distributive property. All right. In the next set of problems, I was trying to emphasize 2 days ago that there's a relationship between the x minus 6, and if I replace the x with a square root, that you're going to find that when we're finished with these problems, we're going to have some, at least in terms of generic rectangle, some similar answers. And I asked you a couple days ago to look for patterns. We're going to kind of continue that discussion here. So if you complete the 2 problems on the left, and then finish the 2 problems on the left, that's the x minus 6 and the x plus 5 combined squares, turn the video back on. So I go ahead and demonstrate this with a generic rectangle. So x minus 6 times another x minus 6. So we end up here with an x squared minus 6x minus 6x and positive 36. So the final answer is x squared minus 12x, and that minus 12x is coming from here, plus 36. In the second problem, again, if I do the generic rectangle, so x times x squared, 5 times x is 5x, x times 5 is 5x, and 5 times 5 is 25. So final answer is x squared plus 10x plus 25. Again, that 10x is coming from adding those 2 terms there, they're called like terms. The reason why I had you do the 2 problems on the left, one of the things I emphasized from on Monday was the fact that when we do the problem on the right, in terms of with respect to the generic rectangle, you should end up with these 2 numbers, a negative 12 and a 36, and a bottom one, a 10 and a 25. So if the generic rectangle is being done, those 2 numbers will show up in that final generic rectangle answer. We also talked about that once we got there, because we are squaring, still squaring, in this case, a square root now, that there was some additional simplifying. But in terms of the generic rectangle, you should see it have a minus 12 somewhere and a 36, and again, a 10 and a 25. So if you go ahead and make the generic rectangle for the first problem, and when you're finished, turn the video back on, especially if you don't have that minus 12 piece and that plus 36 piece. And I will take a look at the problem with the rectangle. All right, so this problem here, we have square root of x minus 3 and then minus 6 times the square root of x minus 3, again minus 6. So we're taking the square root of x minus 3 times the square root of x minus 3, so that means we have the square root of x minus 3, and that's being squared. We're taking it times itself. In the top left corner, we're taking negative 6 times the square root, so we end up with negative 6 times the square root of x minus 3. In the bottom right, we're taking the square root times the negative 6, so we end up with negative 6 times the square root. And in the top right corner, we're taking negative 6 times negative 6, which is 36. So here's that 36 I was talking about. Again, we're going to end up with a 36, and we're also going to end up with a negative 12 in the final answer from the generic rectangle. So in the bottom left corner, we have the square root of x minus 3 being squared. So the x squared is now the square root of x minus 3 squared minus a 12. And that 12 is coming from here, just like it came from the 12 came from the negative 6x and negative 6 on the left. The 12 this time is coming from the negative 6 times the square root of x minus 3 and the negative 6 times the square root of x minus 3. So we have basically negative 12 times the square root of x minus 3. So we have 12 of those. And then the top right corner, we have that plus 36. Now in this problem, I'm going to erase this and put the answer up so that's a little more room to write, but in this problem here, we still have some simplifying to do because, like our previous work, we still have a squaring of a square root, which means the first term in this answer can be actually simplified. But I want you to look at, before I erase it, I want you to look at the fact that if you look at the first answer, one problem on the left, look at the problem on the right. In both cases, we have something squared minus 12 times something plus 36. And the only difference between the two answers is the one on the left, we're using x, and the one on the right, we're using the square root. But other than that, the answer is pretty simple. So again, like we've been doing, we're squaring a square root. We can simplify this expression. So if you go ahead and simplify the first term, and then combine like terms, and see if you get the correct final answer. Turn the video back on when you're finished with simplifying. Take a look at that problem, and then I will have you complete the bottom right problem. So anytime you're squaring a square root, it's going to become x minus 3, because the squaring is with the square root makes an exponent of 1. Minus 12 times the square root, plus 36. The minus 3 and plus 36, those are like terms, are both constants. So we end up with the final answer of x minus 12 times the quantity of x minus 3 plus 33. Since 36 minus 3 is 33. So in the bottom right corner, if you would complete that problem, again, like the top two problems, the problem on the right is going to have a 10 in it and a 25 in it, just like the problem on the left has. So if your generic rectangle doesn't give us that plus 10 times something, and that plus 25, then you've done something incorrect in your generic rectangle. When you're finished, turn the video back on. Alright, so this problem here, the square root of x plus 2 plus 5 times square root of x plus 2 plus 5. So in the bottom left corner, we're taking the square root times itself, so it's going to be the square root of x plus 2, and that's being squared. And then the top left is 5 times the square root of x plus 2. The bottom right is the square root of x plus 2 times 5, so we get 5 times the square root of x plus 2. And in the top right corner, it's 5 times 5, which is 25. So the first answer is our answer being squared, which is the square root of x plus 2, 20 squared. That would be this answer here. The 10, which is the 10x, is actually 10 times the square root of x plus 2. So you have 5 of those in the top left corner, 5 in the bottom right, so you have 10 square roots. Plus the answer in the top right-hand corner, which is plus 25. So again, you look at the two answers, the numbers are the same. They both have a 10 and a 25. Again, the only difference between them is that problem on the left, we're using x, where in the problem on the right, we're using the square root of x plus 2. Go ahead and complete the simplifying as we did the problem above it, and then turn the video back on when you're ready to continue. Alright, so this is going to be the last problem for this video. So I square this, I end up with x plus 2 plus 10 times the square root of x plus 2 plus 25. You have a common term of 2 and 25 are constants. So we're going to add those together. So give us a final answer of x plus 10 times the square root of x plus 2 plus 27. In the next problems, this is where the homework problems come in at. So if you were absent, we'll be going through those next set of problems. Otherwise, the next set of problems in your handout should be just for you checking your homework to see if you did the problems correctly. Please click on the next video, and we'll finish up the handout.